Hi everybody. Today we are going to discuss about the semiconductor material. Because the semiconductor material only, I will do the conductive materials and how because we have insulator and semiconductor and conductor. In that, the semiconductor is very important for the electronic component. Mainly, the basic semiconductor materials is the importance of the material. The electronic gadgets, the semiconductor is very important, like the camera, mobile phones, internet facilities, storage devices, external storage devices, memory cards, processor unit, laptop, everything. The semiconductor material is very important, and also the utilization is limited. So, under the quality of the semiconductor and the network design technique, the limits of manufacturing and the processing equipment also is very difficult. And also, the semiconductor materials is mainly used in all the electronic components and electronic devices. Mainly the Germanium, Silicon, and the Gallium arsenide are mainly used in the semiconductor devices. And also, the special classes of elements having the conductivity between the insulator and semiconductor, insulator and the conductor. So mainly the single crystal having Germanium and the silicon, the compound having the Germanium sulphide, that is GaAs, and also the gallium arsenide, that is GaAs, and also gallium nitride, GaN, and the gallium arsenide phosphates, and GaAsP. After the discovery of this diode, in 1939, the transistor in 1947, germanium is commonly used in the material, and also germanium is available in the pure from the due to the refinery and probably availability in the large quality. So this is the main thing of the semiconductor materials. However, the transistor is conducted from germanium suffered low levels and also reliable due to the sensitivity to the temperature changes. And also due to the scientist having the comp of the silicon transistor in the 1954, which is less sensitive on the temperatures. Silicon is one of the most abundant and material. The electronics becomes highly sensitive to the speed. And also the operating to higher and higher speed, and the communication system were operating at the higher level of the performance. Also the results is the 1970s, the gallium arsenide transistor was developed. The new transistor speed is 5 times greater than the silicon transistor, and also it's difficult to manufacture as compared to the silicon and the germanium. The covalent bond, mainly the covalent bond or the conduction bond, is the intensive material. Even the atoms is made up of the protons and the neutrons, and include the electrons is removed from the around the silicon has the 14 orbiting of electrons, germanium, the 32 electrons. We have the 31 electrons, and the arsenic and 23 orbiting of electrons. In the silicon and the germanium is mainly focused in the group of elements. And also, the electrons is almost outermost of the orbit is called as a valence electrons. Atom having 4 electrons, the valence electrons is called as a tetravalent. Those having the 3 valence of electrons is called as a trivalent, and also having the valence band of covalent numbers also called as a tetravalent. Now, the bonding of atom strength is a sharing of electrons is called as a covalent bonding, and also pure silicon and germanium and electrons is from the bonding of arrangement without any adjusting the adjoining of atoms in called as a figure. So we have the silicon and germanium, we have both the holes and electrons is that is possible. It's automatically able to connect, and also the silicon germanium passes through the conduction of electrons. Those figures shows the covalent bond between the two different atoms, and also covalent bond in gallium arsenide atom we have arsine and the gallium arsenide, we have the positive and negative terminal is possible, and also having 3 valence of electrons also arising by electrons is results in stronger bonding the two atoms mainly. And also the gallium arsenide having intrinsic semiconductor material in the group from 1.7 and 2 values, and also having 1.5 into the power of 10. Germanium also having 2. So it's intrinsic carrier. And also the silicon and germanium gallium arsenide have the relatively the electrons move through the materials, have the differ in the free electrons of the ability, and also the mobility of the factor will be increasing. So 1500, 3900, 8000. The gallium arsenide have the high rating mobility of the factor is available there. And also the energy level band gap is also high. We already discussed the EG to EC, there are conduction band to energy bands, valence bands, conduction for strong conductor, insulator, semiconductor, material, this conductor and so the conduction band and the valence band are the same, very to each other. And also the conduction band and the insulator and the semiconductor, the conduction band gap is high. In these three, the insulator has a more band gap and semiconductor has a little bit less, and the metal having the closely contact with each other. Mainly, the electron between the electrons, where the voltage, where energy is Q and charge is Q, we have the conduction of one electrons. To be different, Germanium has the zero point 0.6 electron volt and the silicon has the 1.1 volt and gallium arsenide has 1.43 electron volt needed to start to conduct the energy gap to fulfill the energy. The constant values. We have the Germanium silicon and the gallium arsenide 0.67, 1.1, 1.43 respectively. And also the extensive semiconductors having the open doping process and also doping, adding up impurities in the semiconductor material, what we have. Now semiconductors intermediate material. Mainly the intermediate is pentavalent and intermediate having contain like antimony and arsenic and phosphorus is mainly we are using for the extensive semiconductor material for the doping of adding impurities in the material. And also we have the N metal having the 5 valence band and also connecting the donor atoms and electrons. We have results. We have the carry the electrons from covalence band to conduction band, so automatically move from the electrons move from the free electrons. So it's a p-type material like this. It will move silicon and also having the holes is the electrons and the holes that will be take places, and we'll have the accepting that covalence and conduction band. So start conducting the electrons to move from one place to another place. So automatically the bonding will be take place and also move and the conduction valence. So adding of boron, silicon and indonium will be adding the impurities and also start conducting the trivalence band gap.